limited here, so we can say kinetic energy very small. Kinetic energy is quite low. Low kinetic energy, right? Why? Because there is limited movement. Yes, inshallah, Zayam, yes. Right? So kinetic energy is minimal. Close to no kinetic energy, right? The least kinetic energy among these states of matter. Now let's discuss liquids. For liquids, the particles are quite close to each other, but there are more empty spaces in between. So I'll just make it with a different color. So for example, we have this. So compared to solids, there are more spaces, empty spaces in between. And the pattern is not regular. The pattern is not regular. So we say irregular pattern. We don't see the neat rows that we saw in solids. Irregular pattern. We can also say the particles, now they move around. Unlike solids. In solids, they could only vibrate about their fixed position, right? So this particle could have moved here, like just vibrated, not moved, vibrated in these directions. But overall, its position remains the same. It just vibrates here and there and comes back to its original position. That is not true for liquids. In liquids, the particles can slide over one another. Slide over one another. That means it can move around. They can move around. Within this confined space of a liquid, it can move around here and there. Now, the particles are still quite close to each other. The molecules in a liquid are still quite close to each other, which means they still have very strong forces of attraction. Not as strong as solids. Solids have the strongest forces of attraction, which keeps them very close, but still very strong forces of attraction. So we can say fairly strong forces of attraction. Now here, because the particles can move around here and there, so we'll say compared to a solid, the kinetic energy is greater. Kinetic energy is higher than solids. Not as high as a gaseous state, which we'll discuss in a bit, but higher than solids because the particles can move around. So in this liquid, so for example, this is particle A here. This particle A can move around. It can move from here to here or here to here, like within this confined space of the liquid. It can move here and there. It's not just vibration now. They can move around. Okay, now another characteristic of these liquids, they have no fixed shape. No fixed shape. Because they have no fixed shape, they will always take the shape of the container. If we put a liquid, for example, if we put water in a glass, that liquid takes the shape of a glass. If you put it in a jug, that liquid takes the shape of a jug. If we put it in a syringe, that will take the shape of the syringe. Why? Because it has no fixed shape, right? And for a solid, the shape is fixed. Fixed shape for a solid. So if we take, let's suppose we take a solid cuboid. If you put it in a jug, the shape of that cuboid remains the same. Doesn't matter if you put it in any container. If you put it in a glass, the shape of the solid remains the same. So we say it has a fixed shape, unlike liquid. Okay, now volume. Volume is the space occupied by an object. I'll write it here. Volume is the space occupied by an object. Now the volume of solid and liquid, volume is fixed. Why is it fixed? You see, in a solid, the particles are arranged somewhat like this. You see these spaces, empty spaces in between. There are close to no empty spaces in between. And for a gas, the arrangement would be somewhat like this. So you can see for a gas, there are so many empty spaces in between, right? But for a solid, this is a solid, this is a gas, and for a liquid, not a regular shape, but limited spaces in between. So for a liquid, you can see the spaces in between are very limited. So is the case for a solid. So for a solid and for a liquid, they have a fixed volume. Fixed volume means we cannot compress it. We cannot bring particles closer together because there are strong forces of attraction between particles. There would be repulsion. So for example, this is particle A of a solid, this is particle B of a solid. When we try to compress them, there would be repulsion between these particles. Right, so they cannot be brought closer together. There is no space available for them to be brought closer together. So we can say for both solids and liquids, they have a fixed volume. Because both of them have a fixed volume, they can't be compressed. Anything that doesn't have a fixed volume, that can be compressed. So for a solid, it can't be compressed. Same is the case for a liquid as well. It has a fixed volume. An experiment here for the volume would be, if you take like 100 cubic centimeter of water, if you put it in a glass, it would be 100 cubic centimeter. If you put it in a measuring cylinder, it would be 100 cubic centimeter. If you put it in a jug, it would still be 100 cubic centimeter. Volume is fixed for a liquid. Because it has a fixed volume, it can't be compressed. Can't be compressed. Is this making sense? Any questions up till now? Any questions up till now? Okay, now for this gas, the particles are far away from each other, somewhat like this. A lot of empty spaces in between, aren't there? So the first thing that we see is we don't see the neat rows as we saw for a solid. So we'll say irregular shape. Irregular shape. Just like liquids. So irregular shape or irregular pattern, you can say. Because these particles are so far from each other, so forces of attraction must be minimal, right? Forces of attraction are stronger when they are close to each other. Here they are far away from each other. So we can say forces of attraction are weak. So they have weak forces of attraction. For gases, these particles, because there are so many empty spaces in between, these particles can freely move around here and there. So for example, this particle A can move around here or here or here, all these particles, like everywhere within this confined space, because we have closed it from the top. So anywhere within this confined space, it can move around. So we define its movement as these particles move freely in all directions. Move freely in all directions. Okay, they can move freely in all directions. Next, highest kinetic energy